Greetings. Hello, everybody, and welcome back. And thank you again for tuning in, as always. So we're gonna do for lesson 10. I have a question here, question 5. So this question comes from 2023 GP Gauteng province. Okay. So we're gonna do it together. 5.1, they say aspirin is known by the chemical name acetyl salicylic acid. The empirical formula of aspirin consists of 60% carbon, 4.4% hydrogen, and oxygen. So the percentage for oxygen is not given here. Okay. You can see that the percentage for oxygen is not given, but you can find it, isn't it? The first question here, define the term empirical formula. We have to define empirical formula. That's the first question. So you can see, guys, that the definition for empirical formula is very important. It is repeated a lot of times, so you should know it, okay? This is easy marks. If you know definitions, you get easy marks here. These are easy marks to pick up. It's just memorization, isn't it? You have to remember. So this is the simplest whole number ratio. The simplest whole number ratio of the atoms present in a compound. Present in a compound. Okay, so it's just the simplest whole number ratio of the atoms that are present inside a compound. Okay. And then for 5.1.2, we're required to find the empirical formula, isn't it? So determine the empirical formula of aspirin. Okay. Determine the empirical formula of aspirin. So, well, to get the empirical formula, we should have the percentages of all the things. So we should find the percentage for oxygen first. See? So we're going to say 100% for 5.1.2. The first thing we have to get here, the oxygen percentage. We're going to say 100 minus 60.0 and then plus the other percentage, which is how much? It's 4.4. 4.44. 4.44 equals to. So you use a calculator. And it gives me 35.56. So now when we have the percentage, then we can get down in it. We can go to the table. So then we write on the element G over 100G, G over 100G, then N, the number of moles, which is M over M, capital letter here, and then we have the simplest ratio. Simplest ratio, last column. Sure. So we write down all the elements. Okay. So we have CHO, C, H, then O. So then underline. That's for C, that's for H, and that's for O. So now, for O, we just found it, isn't it? It's 35.56. 35.56. The H is 4.44. The C is 60.0. So then to get the number of moles, we're then going to divide, isn't it, by the molar mass. So for C is 12, for H is 1. Here we have 16. So all the numbers from here, they go on top. Okay, they go on top. So it's 4.44. So you can see we're going to get 4.44 here. And then 60 divided by 12 is going to give us 5. Then 35.56. You may need a calculator here. So, okay, 35.56 divided by 16. I get 2.22. And then all the numbers here, they go on top. Okay, this will come on top, 5. And then this will also go on top. This over here will also go on top, 2.22. Okay. Then we divide by the smallest. This is the smallest number to get the ratio. So it's 2.22. So it's going to give us 1. And then 2.22. It's going to give us 2. Then 2.22. You use a calculator here, it gives you 2.25. Okay. Now, guys, remember what I said is that the ratio can be inside the table or it can be outside. Okay. Depending on what? Remember that the ratio has to be a whole number, okay? It doesn't have to be a decimal. So if we get our ratio here as a decimal, we use multipliers. Do you remember? Depending on the type of decimal. So if you have anything 0.25, okay? Anything 0.25, go to the first lesson when I was introducing this. So anything 0.25, we're going to multiply by what? We're going to use 4, okay? So meaning we're going to multiply all these things by 4. I gave you a table of multipliers, remember? When I introduced the what? The empirical formula and the molecular formula. So we're going to multiply this by 4 here, okay? We get what? We get 9. We multiply by 4 here, we get 8. We multiply by 4 here, we get 4. So now the ratio becomes outside the table. So it means therefore, therefore, the empirical formula is so the empirical formula is C9H8O4. Okay, empirical formula. So the ratio is outside the table. So there is a table of multipliers. I gave you the table of multipliers that you use in each case, okay? Depending on the decimal. I hope you remember that. Go back to the table if you can't, okay? Go back to that table. The table of multipliers, I gave it to you. So, okay? So now, this is 5.1.2. Okay, so that's the end of 5.1. So we have to go to 5.2, okay? 5.2 is on the next page. So 5.2, oh, there is 5.1.3. They say if the molar mass of aspirin is 180 grams per mole, what is the molecular formula? Okay, so the molecular mass of is 180, né? Molecular mass is 180. So for 5.1.3, isn't it, we have to say N and then empirical formula and then equals to M. So this means that N and then empirical formula. Empirical formula is what? 12 multiplied by 9. So we take the empirical formula, okay? And then 4 times 16. And then equals to the M. The molecular formula here is 180. Okay. So when we add everything up here, you use a calculator there. We add everything on a calculator. It gives me 180. 180 equals to 180. Oh, so it means therefore n will be equal to 1. Oh, so if n equals to 1, it means we have to multiply everything by 1. Okay. So it means therefore it doesn't change. So therefore the molecular formula is over 4. So the molecular formula will be the same as the empirical formula in this case. Because why? Because our n is 1. We divide 180 by 180. We take the 180 here, we divide it by the other 180. So our n is 1. So 1 does not make a difference. If you multiply by 1 everywhere, it doesn't make any difference. Okay. So now, so yes, we can move on to 5.2 now. Okay. 5.2, let me do it this side. Let me do 5.2.1 here. Oh, no, it's just 5.2. So 5.2, what they're saying to us is the following, okay? That the molar mass of hydrated sodium carbonate is found to be 268 grams per mole. The formula of the hydrated sodium carbonate is, so they give us the formula, okay? So this is sodium carbonate, and it is being hydrated, meaning it has what? Moles of water. Calculate the number of moles of water X in the compound, okay? So this is the number of moles of crystallization. So it is going to be the crystallization moles. So we go to the table, what? For crystallization. So instead of having an element here, we're going to have a what? Compound. Yeah, okay. So now we have a compound. We have G over 100 G. And then we have what? We have N equals to M over M. And then we have the simplest ratio. Simplest ratio. So our two compounds, remember I said that for crystallization, there's always 2 compounds only. They can't be 3 or 4. So here I said that it's always H2O here. And then I said that over here, the molar mass is always 18. So now, what we have here is what? So for our question here, so the other compound that we have here is what? Sodium what? Carbonate. Isn't it? That's what they said. So sodium carbonate X. Calculate the number of moles. So what we're required to here is to find X, isn't it? Rated cover was found to be 268. Okay. So we have to find what? Sodium carbonate alone, isn't it? So we're going to say, so sodium carbonate. Okay. Sodium carbonate, the molar mass, isn't it? Sodium carbonate will be equal to, so 23 times 2, bring it up. So that's for sodium. These numbers come from the periodic table, and then plus 12, and then plus 16 multiplied by 3, which is going to be 106 grams per mole. 106 grams per mole. So now for sodium carbonate, this is, it's going to be 106. And then in order to get H2O, okay, in order to get H2O, we should go to our question here. So they say the molar mass of hydrated sodium carbonate is found to be 268. Okay. So we're going to come here. We say 268 minus 106. So the molar mass here for sodium carbonate is 106. So it's going to be 106 over 106. So our answer here is 1. And then when we subtract the 2, we get 162. So it's 162 divided by 18. And then, so the simplest ratio again here. So 162 divided by 18, you use a calculator there. So it gives me 9. So, okay, so you're going to say 1 and 9. And then you divide by the smallest, which is 1. So you divide by 1, you divide by 1, you get 9, you get 1. Okay, so this means that therefore the X, we get it from here, from H2O. So we get it from here, from the simplest ratio. Okay, so it means therefore X equals to 9. That's our answer. Okay, that's the X that they're looking for here. Number of moles of water, X, in the compound. See? Okay, so yes, we're gonna leave it here for lesson 10. I just thought I'd bring you one question on what? On crystallization, so you can see, okay, how it's done when we're using compounds here instead of elements. So this is where we're using compounds instead of elements. Okay. Because we're looking for the number that we're looking for is this one here, the simplest ratio for what? For H2O, which represents X, or sometimes is N, the number of moles of water of crystallization. Okay. So we're gonna leave it here. Okay. Thank you for tuning in. Leave your questions, please, in the comment section. And if there's anything you don't understand, leave your questions in the comment section. And thank you for tuning in. Stay focused, study hard, and stay focused. Bye bye for now.